morning students. Welcome to Lakshya Academy YouTube channel and please subscribe to the channel. Today we discuss a second year topic, semiconductor devices. That is the last chapter of your second year syllabus. Today we discuss about semiconductor electronics, materials, devices and simple circuits. Okay, students, listen carefully and write down the notes. First of all, what is a semiconductor electronics? What is meant by semiconductor electronics? Semiconductor electronics is the branch of physics which deals with the electron flow through vacuum or gas or semiconductors. So it is the branch of physics which deals with the electron flow through vacuum, gas or semiconductors. So I divided this total lesson into 4 parts. In first part, we discuss we learn the topics energy bands in solids, energy band diagram, metals, semiconductors and insulators, and what is intrinsic semiconductor and what about the intrinsic semiconductor, and the concept of electrons, holes and doping of a semiconductor, and what about extrinsic semiconductor and types of semiconductors, and current flow in a semiconductor, and distinction between pure semiconductor and impure semiconductors, and conductivity in semiconductors. First of all, classification of substances on the basis of conduction of electricity. All the substances cannot allow electricity through them. So, on the basis of electrical conduction, classification of substances. Students, a substance is made up of molecule, and molecule is made up of atoms. And substances are mainly classified into 3 categories: solids, liquids and gases. And in solids, atoms are at definite positions and the average distance between them is constant. That means intermolecular distance remains constant. And in microscopically, generally substances are classified into 5 categories, that is solids, liquids, gases and plasma and Bose-Einstein condensate. But mainly the substances are classified into 3 categories only: solids, liquids and gases. Next thing, depending on the internal arrangement of atoms, solids are further divided into 2 groups. On the basis of internal arrangement of atoms, solids are divided into 2 groups. First one is crystalline solids and the second one is amorphous solids. After we discuss briefly about crystalline solids and amorphous solids. Okay, this is the classification on the basis of internal arrangement of atoms. Crystalline solids. What is meant by crystalline solid? The solid in which the atoms are arranged in a regular order are called as crystalline solids. Once again, I repeat, students. The solid in which the atoms are arranged in a regular order are called as crystalline solids. And In other words, we can say that in a crystalline solid, there is a periodicity and a regularity of its component atoms in all directions. It means that, so in the case of crystalline solid, the periodicity and regularity of its component atoms same in all directions. For example, consider sodium chloride, common salt, or diamond, sugar, silver. All these are examples of crystalline solids. The examples of crystalline solids are sodium chloride, common salt, diamond, sugar, and silver. In all these examples, in the crystalline solids, their atoms are arranged in definite geometrical shape. So crystalline solids have the definite geometrical shape. And crystalline solids have a definite melting point also. Crystalline solids have a definite melting point, and they are anisotropic. What is meant by anisotropic? Crystalline solids are anisotropic. What is meant by anisotropic? The substance which have their physical properties such as thermal conductivity, refractive index are different in different directions, and that property is called anisotropic nature. So crystalline solids are anisotropic in nature, and these are crystalline solids are real solids. And another point also here, crystalline solids have sharp freezing point. When we cut a crystalline solid with a knife, we obtain a flat and smooth surface. When we cut a crystalline solid, we get flat and smooth surface. Next thing dear, amorphous solids. The solids in which the atoms do not have definite arrangement are called as amorphous solids. And amorphous solids are also named as glassy solids. And amorphous solids do not have the regular arrangement of atoms. The examples of amorphous solids are glass, rubber, plastic, powder, etc. They do not have definite arrangement of its atoms, so they do not have a characteristic geometrical shape. And amorphous solids are isotropic. Their physical properties such as conductivity and refractive index are same in all directions. Amorphous solids are isotropic in nature. And amorphous solids are not real solids. In some of the books they mention that they are pseudo solids. Amorphous solids are not real solids, and they don't have the definite arrangement of atoms. That means the intermolecular distances are not equal. That is the main difference between amorphous solid and a crystalline solid. And amorphous solids do not have definite melting point also. Okay students, this is the brief discussion about crystalline solids and amorphous solids, and the total description of crystalline solids and amorphous solids you discuss in chemistry part, solid state chemistry. Okay students, did you get classification of crystalline solids and amorphous solids? And this is the classification of solids on its structure, on the basis of its structure. Next, we move to next topic, that is classification of materials on the basis of conductivity. Electrical conductivity or specific conductance is a measure of material's ability to conduct electric current. Electric resistivity, also known as specific electrical resistance or volume resistivity. On the basis of electrical conduction, solids are classified into three categories: conductors, semiconductors and insulators. The substances which allow electric current easily through them are called as conductors. Conductors have very low resistivity and very high conductivity. The resistivity of conductors is in the order of 10 power minus 2 to 10 power minus 8 ohm meter, and the conductivity of conductors is about 10 square to 10 power 8 Siemens inverse. And examples of conductors are copper and nickel. Insulators, substances which do not allow electric current through them are called as insulators. These substances have very high resistivity and low conductivity, and resistivity is in the order of 10 power 11 to 10 power 19 ohm meter, and conductivity is in the order of 10 power minus 11 to 10 power minus 19 Siemens meter inverse. And examples of insulators are wood or rubber. The substances which have the resistivity and conductivity lies in between the conductors and insulators are called as semiconductors. And these substances have the resistivity in the order of 10 power minus 5 to 10 power 6 ohm meter. And conductivity 10 power 5 to 10 power minus 6. And the best examples of semiconductors are germanium and silicon. Germanium and silicon are the examples of semiconductors. Classification of solids on the basis of electrical conductivity. Conductors are those substances through which electricity can pass easily, and examples, all the metals are conductors. All the metals are conductors. They can allow easily electricity through them. Next one, insulator. Insulator are those substances through which electricity cannot pass. The best examples of insulators are wood, rubber, etc. These substances do not allow electric current through them. Next one is semiconductor. Semiconductors are those substances whose conductivity lies in between the conductivity of conductors and insulators, and germanium and silicon are the best examples of semiconductors. And this is the first part here. In the next part I continue the lesson.